Good morning, students. Am I audible to every one of you? Yes, students, am I audible to every one of you? Hello. Hello, everyone. Hello.
Yes,
Yes, sir.
yes, sir. Yes, sir.
Okay. So let us start. Okay, today I'll basically show you a presentation on beams. So actually, what happens is that I just wanted you to make you familiarized about what is actually beam is. In the last class, we have been discussing all these things, right? And many of you might have some doubts. So this in this type I'll just make you familiarize with beams. Okay, so without waiting, let us start. First of all, we have applied and reactive forces. So the forces that are applied on a body, they can be divided into two types. Primary, okay, in primary types. Number one is applied, and number two is reactive. So what is actually applied forces? Now look, in a structure, applied forces means the forces which are applied to the structure. Got it? That means there may be certain loads, dead load, live load. Okay, so those are what? Those are the applied forces. Now coming to the next is what? Next is your reactive forces. So reactive forces means what? The reactions that are being actually generated. Hmm? Now, in case of support, now a beam that may be simply supported, that may be like cantilever, that may be overhanging, that may be continuous. So in this kind of beams, there are lots of supports. So the supports are what? Basically connect structures. That means these are structures that are basically used to connect the beam or whatever beam with the ground. Okay, so they are mainly capable of restricting the external forces that are acting on the beam. Huh. So these are known as supports. Now look, if you try to hang something, if you try to hang something, then what happens is you have to hang it with the help of what? Certain supports, right? So those are actually the different types of supports. Now let us go. Now look, basically in beams, for beams, what happens is that there are three type of supports that are in beams. Number one is roller, number two is hinge, and number three is fixed. What is roller support first of all? So roller support means what? Roller support is the type of support in which, hello, can you all hear me? Can you all hear me?
We
Yes,
are
sir.
listening. Yes, sir.
So first of all, there is what? There is roller support. Roller support means these are the supports that are present in the form of a roller. Now look at this. So if you see this figure, if you see here, if you see here, okay, so these are what? These are two rollers, right? That means what? That means what? These rollers are basically the supports of the beam. Suppose if you assume this to be a beam, then that means what? These are the two roller supports. Now look, these roller supports can be, surface of the roller support can be horizontal, vertical, or sloped at any angle. Okay, so the supports can be horizontal, vertical, or sloped at any angle. Look at this figure now. This is what? Horizontal. This is what? Vertical. Right? I'm using a pointer. Can you see the pointer? Hello.
Red one, like a laser.
Yeah, like a laser. Okay, that's good. Yeah. So the surface can be what? Horizontal, vertical, or sloped at any angle. Now the resulting reaction force. If you all are aware from Newton's third law, you all know na, every action has an equal and opposite reaction, right? So if every action has an equal and opposite reaction, then what happens? Can you all say what happens? Suppose there is a force, I mean, there is this support, right? So definitely this bottom part will give some reaction from the top load, because if a load is applied from here, if you apply from here, that means suppose someone is standing on here, in this part, then to counteract this, so there will be an opposing force, right? So these two opposing forces will be present, and they are what? Balancing each other. Hmm. So this is what the resulting reaction is for roller support. Got it? Now, if you come to the next one, this is basically a practical example of roller. Suppose these are all rollers, right? So in this way, this roller is present, then this will be the reaction that will be given. Okay, look at this. Now, if you see, for this time, only learn only the basics. Okay, we'll go in details. So you can, we'll have solid mechanics in the next semester. So we'll be going in details in that course. Right now, you just learn about the basics. Look, if this is the roller, because this is a wheel, so wheel can be considered as a roller, right? So here it is giving some reactions. Now, if you can see from the derivation, this may be horizontal, or sometimes this may be what? Inclined also. So this is what roller supports are actually. Now we go to what? Hinge support. We go to the next one, which is called hinge support. What is actually hinge support? Hmm. So hinge is what? Hinge is a hinge is what? Hinge can resist both vertical and horizontal forces, but not a moment. Now moment means what? Moment was force into perpendicular distance, right? Now if you can see in the next slide, look at this. So here, if there are some circular members present, then we could have denoted it as a roller. But right now, it is not a roller, but it is a hinge. So in hinge support, what happens? It has can resist both vertical and horizontal. Look, for this portion here, there may be shear forces from this side as well as this side. So if a hinge is there, then it can resist both these, but it cannot resist moments. Okay, so this is a practical example of a hinge. We have already always seen these things in your doors. This is basically a practical example of hinge support. Okay, door hinge. So these are certain door hinges, if you can see here. Okay, now the difference between the hinge and roller. Okay? How will actually the reactions take place? Now here, if you see figure B and figure D, figure A is what? Figure A is a hinge support, and figure C is what? A roller support. Got it? So if these two are different, then what happens is that these two are different. Then what happens is that there are two reactions that are being applied. This one and this one. Right. These are the two reactions that are being applied. Then what happens? In case of a hinge support, there it can resist both vertical and horizontal, what do you call it, forces. But in case of roller, what happens? It can resist only the force that is perpendicular below, right? So this is what the roller is all about. Now there is the third one. So we got to know means roller. Now there is the third one, which is called fixed support, right? So what is actually a fixed support? Suppose a structure or a beam is fixed in the support. You can see here, right? So if it is fixed, then what happens is that these two fixed support will be able, like in roller it was only one reaction it can resist. Now in hinge it was in two. Now in fixed, what happens? If the support is fixed, then it can resist both. That means what? The horizontal, vertical, as well as we can see there is the symbol of this. This is what moment. So it can resist all of the three. Now this is a typical example of a fixed beam. Hmm. So if you see this example of a fixed beam, so this is the fixed beam. So this can resist actually horizontal, vertical, and moments. All these three can be resisted by this. Okay. Now if you go to the next, can you see this bridge? Can you see this bridge? Hello, hello.
Yes, sir.
Yeah.
So in this bridge, what happens? This is, if this is a fixed support here at this end, got it? At this end and at this end, then this can resist what? This side, from this side as well as the moments. That's simple. Now you can go to the definition of beams. What are the different types of beams? So a beam is a, in the last class we discussed, right? A beam is a structural member that is designed to support the applied load, and it resists the applied loading by a combination of internal transverse shear force and bending moment. Basically, what is a beam? So a beam is a structural member. Huh? It is that structural member which is capable of resisting the applied loading. Okay. Now, a beam is actually the most important structure that is used widely for support. Huh. And it is almost used in all structures. A beam is very much essential in all structures. If you construct any kind of structures. Huh. Now, look at this. If you see the figure, this is a beam and this is the load that is being applied. Okay. So in beams, what happens? Now this is, if you see, consider this to be a beam, the loads are what? Vertical, right? And the surfaces are horizontal. Now can you see the beam of your house? Now if you're inside your house, if you see above, you will see those beams like this, where it is. In the last class I showed you, no? Can you recall which are the beams of your house? Hello?
Yes, sir.
Yeah. So those beams, what happens? In those beams, as the definition says, the beams are always horizontal, but the supports are what? Vertical, right? So this is the difference. So the beams are mainly capable of what? Transmitting the loads. So the action that is involved in beams are mainly shear force and bending moment. Okay. So the actions that are involved in beams are mainly. Now, if you see the type of beams in the last class also, we have discussed about it. So what are the different types of beams actually? Number one is what? Cantilever. Number two is simply supported. Number three, overhanging. Number four, fixed. And number five, continuous. So now, first of all, cantilever. What is a cantilever beam actually? Look at this figure. If you see this figure, what happens is that the one end of the beam is fixed, while the other end is what? Free. Now the load, someone asked me in the last class whether the load can be applied only in the, what do you call it, end or in the middle. Everywhere you can, the load can be applied. The load combinations may be also different, right? So the beam is fixed at one end and it is free like this. This is basically known as a cantilever beam. Now we go to the next one. If you see, these are the practical examples of a cantilever beam. Look, in the railway signals, you all will see like this a projecting structure like this. Look, it is fixed now. So this is fixed here and it is overhanging here. Now the load is applied everywhere. So this can be an UDL and this can be a point load if you think like this. Now here also the same thing is there. The beam is there. Okay. So these are examples of what? Cantilever. Now we go to what? The next one. That is a simply supported beam. Right. So in a simply supported beam, if you see, the beam is simply supported. That means what? There is no fixing. Now if you can see in the right side where the pointer is, so in that kind of structure, what it is actually, that the plank is simply there and it is simply supported at this end and at this end. So this type of beams are called simply supported. Now we go to the next one. What is actually fixed beam? Now a fixed beam is what? In our homes, the beams that are present actually are fixed beam. Why fixed beam? If you see the above, these are basically fixed, no? So if it is in a single room, it is fixed, and if it is in a multiple room, if it is continuous, then you call it a continuous beam. So basically, this end and this end are what? Fixed. So we call it a fixed beam. Now overhanging beam. What is actually overhanging beam? So if you can recall this thing, overhanging beam means what? Suppose the beam is supported by two supports. Hmm? Now, if the beam is supported by two supports, so what will happen? Some portion of the beam is projecting outwards, right? If some portion of the beam is projecting outwards, then this is known as a what? Overhanging beam. Okay. So this is basically an overhanging beam. Now, if you see the next one, look at this. This is a footbridge support. Okay. Now, this portion, the portion which is thus projecting outwards, or maybe of this home also. So these are overhangings. Okay. Now we go to the next one, which is called a continuous beam. So in this continuous beam, what happens is that if you see here, this is a continuous structures, right? Now here there are supports, one, two, three, four, multiple supports. So this is basically an example of continuous beam. Is it clear up to this?
Yes, sir.
Clear now, everyone?
Yes, sir.
Okay. So now we'll go to what? The next topic. What is that? It is types of loads. So what are actually the different types of loads? The types of loads can be defined as concentrated loads. First of all, what is concentrated loads or point load also they are called. So these two loads, this one, this is a what? This is a beam, right? What kind of beam it is? Can anyone say? From the figure, can anyone say what kind of beam it is?
Simply,
Simple support.
Ah,
simply supported.
very good. This is a simply supported beam. So the loads, look at this load. It is acting at a point, right? It is acting at a point. So this kind of loads are called as basically point load or concentrated loads. Clear? Okay.
Yes, sir.
Hmm. So now, apart from point load, there is another type of load which is called distributed loads or maybe uniformly distributed loads. Now look, if you see here in this beam, there is a point load that is acting, right? Huh. So if there is a point load that is acting, this is called a concentrated or point load. Now here if you can see this is a beam, right? So in this type of beam, what happens? The load is in the whole beam. So this type of beam is called UDL or uniformly distributed load. So this is basically an illustration of UDL. Now remember one thing, in our all system of forces or in our all structures, basically we will have UDL or uniformly distributed load in maximum cases. Okay, so this is what is very important. Now the next one is yesterday we discussed last class
Sir.
uniform. Yeah, hello. Yeah, say hello.
According to sir, according to your presentation, so we can say that if there are a lot of many more than one point
Hmm.
load, then we can call as a uniformly distributed load, sir.
No, 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 no. Why? This is the different thing. Do not go to the figure. This is the
Ne-
uniformly distributed load means what? लोड पूरा बीम के ऊपर डिस्ट्रीब्यूटेड है यूनिफॉर्मली, समझा? एक पॉइंट लोड, इफ देयर मे बी
so
लाइक दिस आल्सो. Look, there are 2 point loads here, na? So this is what? There are 2 point loads, but you cannot say this is an uniformly distributed, right? But here, look, it is present all over the beam, and the same amount of load is present. So that is known as an uniformly distributed. Yeah, say. Same as that. What
ठीक
do you
है
want to show?
ओके सर
अभी समझ
ओके
में
ओके
आया?
सर हाँ वो फिगर थोड़ा कंफ्यूज
कौन सा फिगर? ये फिगर ऐसा ही ड्रॉ करने सकते हैं ना?
ठीक है सर
हाँ, ड्रॉ तो डिफरेंटली भी कर सकता है तुम ऐसा. सपोज तुम लोग ऐसा ड्रॉ कर सकते हैं ना? मैं दिखाता हूँ, रुको. सपोज ये एक बीम है, हाँ? तो इधर में तुम लोग ऐसे ड्रॉ करो ना. So this is basically what we draw in our copies actually for determining uniformly distributed load. So this is the beam. These are the two supports, right? So this is what uniformly, or it is called as UDL. Now you can see here for the other type of loads, it is in suppose Newton or kilonewton. Remember, huh? Now, but in UDL, what it is? But in case of UDL, it is न्यूटन पर मीटर. अगर लोड कॉपी में, अगर एग्जाम में अगर ऐसा आया कि लोड न्यूटन पर मीटर या फिर किलो न्यूटन पर मीटर है, तो उसका मतलब समझ लेना तुम लोग यूडीएल है. व्हाई यूडीएल? बिकॉज सपोज दिस इज द डिस्टेंस बिटवीन दिस एंड दिस इज एल meters. So if it is L meter here and here, then what happens? So for 1 meter it is something, right? So for 1 meter it is something. So for L meter it will be L something. Got it? Now clear? Clear here, Abhi?
yes sir
So this is what the basic thing, fundamental. Huh. Now UVL. Look at this UVL. Now in UDL it is per meter. So it will be same towards the entire length. But in case of UVL it is not same. It is totally different. Look, here it may be 1 Newton, here it may be 2, here it may be 3, here it may be 5. So it is varying, but it is uniformly varying. So this type of beam is known, load is known as what? Uniformly varying load. Now look, once the loads are applied, so once after the load is applied, what actually the load do? Load अगर बीम में apply होता है तो load, what happens to the structure? You may be asking that question. So the things that happen mainly is bending. Can you see the bending word here? And shear. Now what happens? Suppose this load is applied here. Now if you take a, I'm giving a simple example. Take two books and take one long scale in between those books. Now if you try to push with your finger like this, if these are the books, so what will happen? It will bend, na? Yes or no? So if it will bend, then what will happen? The bending reactions will come. From that only we develop what? We find out the bending moment. Then it will come to the bending moment thing. And then after that what it comes is shear. Shear means what? In the Last class also we decided shear means what? It is tearing away. Something is being torn away, then it is known as shear. So here in the figure you can see this is a shear. No, so this is what? This is the original beam if in white dotted lines. Now once load is applied, it gets bending, right? And here it is the original one. Now once load is applied here, it gets torn away or it gets broken down in this part. So this is known as what? Shear. We'll discuss about this. Any doubt? May I choba?
No, sir.
Okay, let us stop this presentation till here. We'll go to the theory part now again. Okay, then only we'll come to the next these things. Huh. So now, are you clear with what is being taught now, or you have any doubts? Is it clear? Hmm? Any doubt? Students, I'm asking you. No doubt, no?
No, sir.
Okay. So we'll go. Let's do one thing. Can you see the lectures? Can you see the presentation? Hello. Can you see the presentation? Huh?
No, sir. Nothing.
Wait,
No,
wait,
sir, nothing.
wait a minute. Now, now.
Yes, sir.
Okay. Just now we discussed regarding sense the terms shear force and bending moments, right? Yes or no? So what is the shear force? At the last class we discussed regarding the shear force and bending moment. Right, shear force is what? The algebraic sum of the vertical forces at any section of the beam to the right or left side of the section is known as shear force. And bending moment is what? Algebraic sum of all the moments of the forces that is acting right or left. Now remember, this figure. Now for shear force, what is happening? We are having certain sign conventions. Okay, so we are having certain sign conventions. That means what? In shear force, we will be having as you can see in the figure, certain sign conventions. Now look, this now look, this suppose this is the beam. Now in this beam what happens? We consider one section. That means what? We basically cut the beam into half as shown in figure. As shown here, we basically cut the beam into half. Now if the force systems are in this manner, it is in what? Clockwise, if you can see. Is it clockwise or not? Like this, no? The force is coming. Yes or no? You can see it is clockwise or not. This is
So,
coming
yeah.
from bottom, it is coming like this and it is going down. So it is what? Basically clockwise. Yes or no? So in clockwise, what? So in clockwise it is what? Positive. And similarly, if you can see here, it is what? This is coming down and this is going up. So this is what? Anti-clockwise. So in this anti-clockwise case, so it is like this, right? So it is what? Clockwise. This one is clockwise and this one is what? Anti-clockwise. So clockwise is considered to be a positive and anti-clockwise is considered to be as negative. Now if you go to this next one, bending moment. So what is the bending moment? Sum of the moments that is acting either right or left side of the structure. Now in case of bending moment, what happens? We have positive and negative. Look, in the presentation I showed you like this, no? Suppose this is a beam, here certain load is applied. Okay, so this is the supports. Now if your load is applied from this side, what will happen? It will be like this. This is what? This is coming out to be, this is known as what? Sagging, or it will sag down. So suppose here it will be the original beam, but eventually it will what? This one is coming down, right? This sagging is known as this. In this phenomenon, the bending moment is considered to be what? Positive. And in the other phenomenon, that means what? Hugging. If it goes up like this, so it is negative. Just as of now, just remember this
Sir,
thing. Ah, bolo.
in hogging, sir, support should be in above the.
No, 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 like this. The supports are same only, but there are, because of certain conditions, it will be like this. The beam is like this.
Condition,
Supports
sir.
are what
It's
condition you need? Then I'm trying to understand now. Suppose this one is what? Simply supported, right? We draw, right? Yes or no? Hello, hello. तेमजा
it's simply supported.
हाँ
Yes, sir.
तो
It's
अभी
simply
हम लोग क्या
supported.
करेंगे? अभी हम लोग एक फिक्स बीम ड्रॉ करेंगे. We are drawing a fixed beam here. Okay. So in fixed beam, suppose there may be certain what? Earthquakes, because of which this portion. Yeah, any problem? Chongtham? Because of this earthquake or something, some disturbances, if this one comes like this and if this one come like this, then that means what? They are coming closer. Then what will happen? It will be somewhat like this, no? Yes or no? If it
Okay,
is
sir.
coming in this side, And if it is coming in this side, then because of certain disturbances, it may be because of earthquake or anything else, then what will happen? It will be behaving in that manner. Are you getting me now? Hello, are you getting me now?
Got it.
Got it? Okay. So this is how the hogging and sagging are different. Got it? Okay. Or we can consider in the direction of the movement also, like this. So if it is in clockwise direction like this, and if this is in anti-clockwise, so this is positive then. Now if it is anti-clockwise in this direction and if it is clockwise in this direction, then it is negative. But the better thing you should remember like this only. It is more confident to remember this manner. As of now, just remember for sagging it is positive, being negative, and for shear force if it is clockwise like this, then it is positive, and if it is anti-clockwise, it is negative. So if you have any doubts, you can ask me.
No from me, sir.
What about others? What about others?
No, sir.
Okay, fine. Did you understand today's part? Did you understand today's part?
Yes.
So I shared a videos in the YouTube link now in the ERP. So you can refer to the PPT from that only. That will be much more helpful for you because I'm explaining there also. If you simply refer the PPT, you may not understand what is there. Okay? Is it okay for everyone?
Yes, sir.
Mm.